Good morning, everybody. Today we discuss the merge sort. This merge sort follows the rules of divide and conquer algorithm. Divide and conquer algorithm. Yesterday, I told you the divide and conquer mechanism. Today, the merge sort also follows the rules of divide and conquer technique. So, in case of the merge sort, first of all, this list is divided into the n number of sublist. It is divided into n number of sublist, not it is divided into the two list. Yesterday we have seen that in case of the quick sort, the given list is divided into the two parts, two sublist. But here today, in case of merge sort, this given array or given single list is divided into the n number of sublist which contains a single element and which is considered to be sorted. And after that, recursively merge all the elements. So how the merge sort works? Now we see, suppose this is the list given to you. This list consists of total 8 elements, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, and the one element is remaining. Okay, the only 7 elements, not the 8 elements. You have given a 7 elements. Now, in the first step, you have to divide the elements. Then you have to divide the elements up to, you will get only a single element. So how to divide? So for that, you have to calculate the middle element. And how to calculate middle element? Lower plus higher by 2. This is 1, 2, 3, 4, 5, 6, and then 7. So lower is 1, higher is 7. So 1 plus 7 by 2, and that is equal to 8. Sorry, 1 plus 7, 8 by 2, that is equal to 4. Means 1, 2, 3, 4. From here, the list is break. So you will get the two lists, 38, 27, 43, 3. And the second list is 9, 82, and then 10. Again, you have to break this into the number of sublist, 1, 2, 3. With this formula, middle equal to lower plus higher by 2. Here, lower is 1. 1 plus 4, 5. 5 by 2, that is 2.5. So again you break this from the two elements. So the first is 38, 27. Then second is 43, 3. Here 1 plus 3, 4. 4 divided by 2, 2. So this list will be break into the two parts like 9, 82, and then next part is 10. Once again, you divide these sublist into the n number of lists because we have the 7 element. So you divide all the elements till you get a single element in every sublist. So once again, you divide these two. 1 plus 2, 3. 3 by 2, 1.5 means you just divide into the middle part, from middle part. So that the first part is 38, the second part is 27. Then once again, this is 1, 2. 1 plus 2, 3. 3 by 2, 1.5. So once again, it is divided from the, after the first element. So 30, then 3. Again, it is divided into 2. So 9, 82, and this is a single element. So it is as it is. So you keep it as it is. Okay, now you see that the each and every element will be separated in a separate single sublist. So this is a sublist 1, 2, 3, 4, 5, 6, 7. Means here you will get the n sublist. The total number of elements are 7. So you will get the 7 sublist. And now you recursively apply the concept of merging. Merging means you just combine the elements. So how to combine? So first of all, you have to make the pair. All of you know that pair means the two elements. So you just make the pairs. So this is the first pair, second pair, third pair, and the last one is a single. So you just left that element. Now this is your first pass, pass one. After merging the pairs, then you just do the sorting. 38, 27. Which element is less? 27. So here 27, then 38. In this 3 is less. So 3 and then 43. Then 982. So as it is 982 and then 10. Now at pass 2, this is pass 1. At pass 2, you have to combine the pairs of pair. You have to combine the pairs of pair. Means in the first pass, you have to just combine the two elements to make the pair. At second pass, you have to combine the pair of pairs. See, this is a one pair. This is a second pair. So you combine the pair of pairs so that you will get the element 27, 38, 3 and 43 in one list, and in second list 9, 82 and then 10. Okay, and now you have to just make all the elements in ascending order. So which is the less element? In the first 3, then 27, then 38, then 43. Again, for the second sublist, you have to sort the elements in ascending order, 9, then 10, and then 82. Okay. Now, at pass 3, you have to combine the both lists, because here you get only the two lists. So now you merge this both the list to get the single sorted array. So from this you have to just sort the elements 3, then 9, then 10, then 27, then 38, then 43, and then 82. 1, 2, 3, 4, 5, 6, and then 7. Okay. So this is the final list, sorted list. So divide and conquer means, first of all, we divide the whole given list into the n sub list till you will get the single array element in a one list. After that, you recursively merge, means you recursively combine. In the first pass, you just combine the two elements to make the pair. This is the first element, this is second element. You just combine to make the pair. So this is a pair. Then in the second pass, you just combine the pairs of pair to make the quadruplet. So this is the first pair, this is the second pair. So here I combine to get the 4 elements. And in the last, we have again the two pairs. The first is 982 and the second is 10. You just combine and then you just arrange the elements accordingly in the ascending order. And finally, at the end of pass 3, you will get whole the list as a sorted list. If you carefully observe, see here, at the pass 1, means this pass 1, you have only the two elements. Means at the general rule is at or in the k pass, you have 2 raised to k element. Suppose in pass 1, the general rule is 2 raised to 1. K means 2 raised to 1 means 2. Then pass 2 means 2 raised to 2, because this is a 2. So that is 4. And then pass 3, according to our rule, 2 raised to k, k means 3. Pass 3 means the value of k is 3. So 2 raised to 3, and that is equal to 8. And now you just check it. This is your pass 1. The pass 1 means pass 1 having the elements 2 raised to 1. See, you have the two elements at the end of pass 1. This is a two elements, each and every except the last level. जी लास्ट लेवल असेल तिला सोडून द्यायचं आहे. त्याच्या आधीच्या सर्व लेवल मध्ये तुमच्याकडे 2 एलिमेंट असायला पाहिजे. सो सी दीज आर the 2 and 2 elements. If you check at the pass 2, then pass 2 means 2 raised to k means 2 raised to 2, that is equal to 4. So here 1, 2, 3 and then 4. 1, 2, 3 and then 4 except the last level. And at the end of pass 3, according to this 2 raised to k, you have 2 raised to 3 elements, that is equal to 8. See 1, 2, 3, 4, 5, 6, 7, and then 8. 1, 2 raised to 3. Okay, 2 raised to 3 near about at the last level. It shows that the near about 2 raised to 3 means 2 raised to 8. 2 raised to 3 means 2 2s are 4, 4 2s are 8. Okay, so this is about the merge sort. And what about the complexity of merge sort? The complexity of merge sort is each and every pass exactly you require the 2 raised to k elements. Means at pass 1 you have 2 raised to 1 means 2 element. At in pass 2 you have 2 raised to 2 means 4 elements. So the number of comparisons you require are the as it is the each and every pass consists of 2 raised to k elements, means the each pass requires the log n comparison to the base 2, and for each pass there are n number of comparisons. Each pass there are n number of comparisons, means we have to compare the first element with the remaining number of elements to find out the smallest element. So that is therefore the complexity of merge sort is n into log n to the base 2. So this is a different than other previous 3 algorithms. The merge sort has the complexity n into log n to the base 2. Why it is a log n to the base 2? Because each pass consists of 2 raised to k element. Okay, 2 raised to k element, and that's why 2 raised to k means what? Log n to the base 2. And in every pass we have to compare the n number of comparisons. So n into log n to the base 2. Okay, now just I want to show you one video with the same technique, so that again you get the clear idea. Okay, so this video is on the merge sort techniques. You see
We have seen,
get the clear idea.
and if there are multiple lists, then we can merge them in different patterns. We have seen that. Now let us see merge sort, that is a recursive procedure, and this is divide and conquer procedure. The divide and conquer strategy says that if a problem is large, then break the problem into subproblems, and if the problem becomes small, then solve it and combine the solutions of the small problems or subproblems to get the solution for main problem. So here the problem is to sort these elements, and we say that the list is very large. Then what is small? So basically if there is a single element, then we say it's small. So single element means we don't have to sort it. So yes, in merge sort we say if there is just a single element, then we don't have to sort it. Otherwise, if there are two elements also, we have to call it as a bigger problem or large problem. If there is a single element, then we say it's a small problem. Merge sort follows divide and conquer, therefore it's a recursive algorithm. Let me write the algorithm, then I will trace the algorithm. Let us see. Algorithm merge sort. What are the parameters it takes? It takes two parameters, that is beginning of a list and ending of a list. So low and high. Then we check if low is less than high, means if low is equal to high, it means there is a single element. Low is less than high means at least there are two elements. So list is large. If low is less than high, then we will find out mid, that is low plus high by 2. What for we are finding mid? Like if I find 1 plus 8 by 2, that is 9 by 2, I get 4. So this will be mid. What for? We say that this problem is large, so we break it into two subproblems. That's what we find mid. Then what to do with the left hand side? Perform merge sort recursively. Perform merge sort on the right hand side recursively. So perform mid, find out mid, and perform merge sort from low to mid, and also perform merge sort from mid plus 1 to high. So by performing merge sort on the left hand side, we will sort this one and we sort the right hand side. So when two lists are sorted, we are breaking this into two lists, and when two are sorted, we can merge them together. So perform merge. Merge from where? Low to mid is one list and mid plus 1 to high. So we pass three parameters. So that's all. This is a simple algorithm for merge sort. This is divide and conquer. How merging is done? We have already seen the procedure how merging is done. But the point here is, when the single array is given for sorting, we are breaking into two sub arrays and we are saying this is one first list and that is second list. So single array will be containing two lists and we have to merge them. So can a single array have more than one list? Yes, a single array can have many number of lists. Let us see how it works. Let us see the tracing. Now based on this algorithm only, I will do tracing. Initially we'll be passing low as 1 and high as 8. So let us take for these set of elements. So first time we will pass 1 and 8. It will find out mid and it will divide the list, and this side, that side. So mid is perform a sort from low to mid, that is from 1 to 4. It will go this side, and it has to go on the right hand side also, but not now, it will go afterwards, but I will draw this one also. So let us take this one. So it will call itself from 5 to 8 on the right hand side. So it has broken them into two lists, first part and the second part, and then afterwards merge. So first of all, let us finish this and this. Now merge sort calls itself. Low is less than high. Yes, 1 is less than 4. So again find out mid and call these two. So it means these four elements are also large. Divide them. So this side 1 to 2 and this side 3 to 4. Now when we take this, again low is less than high. Yes, there are two elements, so this is still large. Again split it. So 1 to 1 on this side and 2 to 2 on this side. Now there are just 1 elements. See, if you have seen previous video, you may know how two-way merge works, two-way merge sort works. See, if you have seen previous video, you know how two-way merge sort works. Now here also merge sort is working in a similar way. One array was given, so it has splitted and then splitted, then splitted. Now it has reached one element. Now one element is there, means it's a single list with one element. Now these two can be merged together. 3 and 9 are merged together. So the first merging is done for these two elements and their result is obtained here. So this is the first merge done. This is the first merge done. It will merge these two elements.
See, the same technique is here. The divide and conquer means the whole list is divided into the small n number of lists. So at the left hand side or the left subtree, you see that the single element 1 and 2 is present here. So you just divide the whole list into the smaller subpart till you get a single element. 1 means 9, 2 means 3. So similarly, again you have to divide the right hand side part, means 5 to 8, and just make the right subtree till you get the single element. Continue.
So 3 and 9 are merged. Then coming to this side, it will split them and get 3 on this side and 4 on this side. Then it will merge the elements. 3 and 4 are merged. So first 9 and 3 were merged. So the result was 3, 9, and now 5 and 7 and 5 are merged. Result is 5 and 7. This is combined. Now it will go back and perform merge here. So this is the third merge. So it will merge these two. So the result is 3579. Now this side is sorted. Actually, we have to sort this whole array. Break it and break it and break it. Now two elements merge, two elements merge. Now merge these two also. So this side is sorted. Now same thing is done on the right hand side also. 5 to 8 is there. So on that side it will divide this from 5 to 6. And that side it will be 7 to 8. And 5 to 6 will become 5 comma 5 and 6 comma 6. Now one element each. This is again splitted, one element. So these two are merged. So it becomes 4, 6. So this is the fourth merging. Then it will go this side. It will split again, 7, 7 this side and 8, 8 this side. So it will split this also. Then again these two are merged. So it becomes 2, 8, one more list. So this is fifth merging. Now as these two are already sorted, it will merge these two. So it becomes 2, 4, 6, 8. So this is sixth merging. And then these two lists are merged to get a single list, that is 2, 3, 4, 5, 6, 7, 8, 9. This is single sorted list, that is seventh merge here. So this is how merge sort works. When a single array is given, recursively it will divide that array into smaller pieces until it reaches one element, then it will start merging them. So you can see that 8 elements were given, splitted, then splitted, then splitted. Now they are merged, merge, merge. So this is the working of merge sort. Alright, so it's similar to two-way, but in two-way merge sort, we just take first two elements, the next two, the next two. But this is divide and conquer, and this is recursive. So it will simply divide, and then that's how it reaches one element. Then it will start merging them. So what is different is only the pattern is changing. The approach, rest of the things are same. Right? Result is sorted, and it is also merging two lists at a time. So it is also two-way. But as it is recursive, we need some another name, so we call it as merge sort. Let us see the time taken by merge sort. So from the tree, the recursion tree, that is the tracing of that algorithm I have done. So I'll show you how the time is, I will show you how much time it takes. See, the merging has started in this level. This was just splitting. So how many elements are merged here? Two elements merged, two elements. Total how many elements? 8 elements are there. 2, 4, 6, 8. 8 elements are merged here. So I will say n elements are merged, all n elements. Then again merging is done at this level. So 8 elements are merged. Then again 8 elements are merged here. So n elements are merged each time. So total how many levels are there? 1, 2, 3 or 1, 2, 3. So total 3 levels are there. So for 8 elements I got 3 levels. It means it is log of 8. Log of 8. 1 and then 2, then 4. So when something is raising by 2 every time, and it is power of 2 lastly, power of 2, that is 3 at the last, we are having 8 elements total. So 3 is log of 8. So how many passes are there? So actually these are not passes because it is recursive. First it will enter this side, then it will go that side. So it is not passes, right? First it will finish left side, then right side. But levels if you see. So total how many levels? Log n levels are there. So this will be n, how many times? Log n times. So the time taken by merge sort is theta of n log n. That's it. So the time for this one is also n log n. Now taking.
Okay. Now I just stop the screen sharing. So this is about the merge sort. Actually, we have seen the merge sort algorithm. The nature of merge sort algorithm is a recursive nature in this video, and the complexity required by the merge sort is n into log n. With this, the simple example and the video, you will clear the concept of merge sort and how to write the algorithm and how to trace the algorithm. So with this, I stop here, and the next only one sorting technique is remaining, that is a tree sort. So that we will continue in the next lecture. Thank